Yes. Very good. Very, very good. So on number 18, if x equals 2 plus cosine t, what does x minus 2 equal?
Cosine t.
Cosine t. Okay? And if this is what y equals, what does y minus 2 equal? Negative sine t. 施力座，你做什么？数学课？ So what can I do to both sides of these? Square them. So if I square both sides of both of these, you get x minus 2 squared is equal to cosine squared t. And what do you get over here? Y minus 2 squared. What happens to that negative? Just becomes what? Oh, now what happens when I add them together? What do I get? Add them together. X minus 2 squared plus y minus 2 squared is equal to what? 1. So what is that? It's a circle with what? Radius what?
1.
Centered at what?
2, 2.
Done. And then you could also say where it starts and what direction it goes in, and that you don't need to do a couple points for. That's it. Parameterize it if you unparameterize it. Unparameterize. Turn it into a Cartesian. Turn it into a Cartesian if you can. If you can. When you can isolate sine and cosine, can you do that? Absolutely. Square it, add them, get 1, done. How are you feeling on that one right there? Could you make a table? Absolutely, sure. You could make a table. I really wouldn't want to because your points are going to be super nice to plot, and they're not going to be super recognizable because what are they going to be like? 2 minus root 2 over 2, 2 plus root 2 over 2, and then you might recognize you have a circle. Just try to unparameterize it if you can. So then you asked about 22, I think. 22. Any idea what you should do for 22? Describe the motion. So what should we do for 22? Substitute. Now, how did you go about substituting, Chip? What did you isolate in which equation? So there's first equation here and the second equation. What did you isolate in which equation?
Well, I said t.
You isolated t in which equation?
T squared.
So you isolated t squared in the second one?
Yeah.
So you had y plus 2 is equal to t squared?
Yes.
Then what?
I substituted y plus 2.
Oh, sure. And then you just took that and plugged it in there. And what'd you get? X equals what? Y plus 2 plus 3. So what does that mean? X equals y plus 5. So y equals x minus 5. There's the path of the particle right there. Could you add in much more information? Where does it start? Could you do that? Which direction does it go in? That you can plot points for to find the direction. Absolutely. Look at the derivative. When is it positive? When is it negative? That kind of thing. But what is the path going to look like? What path is this going to trace out? Y equals? It's a linear function. Yeah, a linear function. We okay with this one? When you are able to unparameterize and do this, turn it into a Cartesian, is it really helpful? Yes. Are you always able to do this?
No.
No, you're not. Sometimes it's really, 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 really challenging to write it as a Cartesian. Absolutely. Okay, so then you had 43, I think. 43? Describe in words the curve represented by the parametric equation. Oh, what is this one again? Anybody finish this one? What is this one? It's a line. We like isolating. Let's do x here. So here, what does t cubed equal in terms of this one? X minus 3. Take that and plug it up there. Y is equal to 5 minus what? So y is equal to negative x what? Plus what? Plus 8. It's a linear function, slope of negative 1. Here's how they write these things out. 43. It's a straight line through the point 3,5 with slope negative 1. A linear parameterization of the same line. It's a linear parameterization. Here's the thing. What's the relationship between this set of functions right here? What's the relationship between that and this? X equals 3 plus t and y equals 5 minus t. What's the relationship between this parametric equation and this parametric equation 1 and parametric equation 2? What's the relationship between them? Yeah, Ian.
The t's cancel out.
No, don't do operations. What's the relationship between them? They each describe the same what? The same line. They're each the same line. What's the only difference? Yeah, how, like, speed and velocity of that particle on the line. When you isolate t in this, when you isolate x and y, not isolate, when you combine these two equations, what do you end up with? Y equals negative x plus 8. You end up with the same thing, right? But the index variable is being cubed in the other one, so theoretically you could say, Chip, I liked what you said, in this one is faster And what's the other one? Slower. That's an overgeneralization, but that's okay to say. You could say just the speed is different at different times. Absolutely. It's going to jump further. Like plugging in 8 right there is the same thing as plugging in 2 in the other one, right? So those two things will be at the same places, but at different what? Times. Different times. Please put everything away except a pencil. K equals 5, do the particles ever collide? Raise your hand if you think so. Do they collide? If K equals 5? Do they not collide? Okay, this is not American democracy. So first of all, please sit down, everybody. Second of all, everybody has to vote here. I know you all did A. Do they collide? No. They do not collide. They do not collide. Collision means they're at the same place at the same time. So you find out when they have the same x coordinate, and that has, for them to collide, that has to be the same when they have the same y coordinate as well at that time. What happens when you try to do that? What happens when you try to do that? What happens when you try to find where they collide? What do you do first? Nope, nothing to do with you don't need the Cartesian. You set what equal to each other? The two x of t's, right? They're the two x of t's. If you set those together, what'd you guys get? 4t minus 4 is equal to 3t. So therefore t is equal to what? 4. So the only time the only time when the x coordinates are equal to each other is when time equals 4. But you said in this one k equals what? 5. So let's set the y coordinates equal to each other. Here are the y components. So 2t minus 5 is equal to what? T squared minus 2t. Is that minus 1 or plus 1? Minus 1, right? What should I do now? What should I plug in for t?
Shouldn't it be 2t minus
k minus 5? If k equals 5. We're still doing A. We're not done yet. We're still doing A. If k equals 5, so what did I do? I made k equals 5. What do I plug in for t now?
4.
Why do I plug in 4? Because that's the only time the x coordinates are the same, right? So what do you have here? 8 minus 5 is equal to 16 minus 8 minus 1. So that's 3 is equal to what? 7. Not true. So do they ever intersect? No, they do not intersect.
Can we actually write it like that?
You would say, I would like a sentence. You could say, the only time the x coordinates are the same is when what? Is that what? T equals 4. But when t equals 4, the y coordinates are not the same. Are not the same. Does that make sense, everybody? Write out the sentence, please. So how do you do B? You find K so that the two particles do collide. Well, what's the only time they have the same x coordinate? We just said it out loud.
4.
Everybody stand up. Everybody stand up. 10 seconds. Stretch, everybody. Stretch. They have to have the same. Also have the same what? Y coordinate. They also have the same. They also have the same y coordinate. So what's that equation we solved that didn't come out to be true? This one right here, right? What was the one value we added into that green box? What was that one value that we added in first? The 5. So we have 2t minus k is equal to t squared minus 2t minus 1. Instead of plugging in k equals 5, what do we plug in for t? We want t equal to 4. So we have 8 minus k is equal to 16 minus 8 minus 1. So 8 minus k has to equal what? So what does k have to be? 1. So the only value of k that causes them to intersect is when k is equal to 1. So that's k equals 1. At what time do the particles collide in part B? Well, k isn't a time, right? At the time, which particle is moving faster? I'm sorry, I didn't see the second phrase there. What's the equation for speed if you have, if it's in parametric? It's the magnitude of velocity. So what's that going to be? The square root of what? Dx, dt, yeah, you can do y first, that's fine, Soma. dy what? dt squared, exactly, right. So you do that in both cases. You can sit down now. So what's the first thing you should find? Yeah, for both of them, right? So you have particle 1 and you have particle 2. So for particle 1, what's dx dt if this is particle 1 right here, the first one?
4.
So that's just going to be what? 4 squared plus what? 2 squared equals the square root of 20. And then for particle 2, what is it going to be? It's the square root of, sorry, this is messy. What is it going to be? 3 squared?
Yeah.
Yep. 3 squared plus what? 2t minus what? 2 squared? But it's going to be at time equals what? Time equals 4. So it's going to be the square root of 9 plus what? 6 squared, right? It's 6 squared, right? So it's 36. So what is it? Square root of what? 45. We can compare them. The square root of 20. Can you break that down for me? 2 root what? 2 root 5, right? What about the square root of 45? What's that? 3 root 5. So which one's bigger? So this one is going to be faster. Are we okay with that? Are we comfortable with that? How comfortable are we with that math? Are we good? Could you do that on your own, you think? Good. Good. Excellent. Let's keep moving here. Get back to the board, everybody. Get back to the board. Get back to the board. Get back to the board. No calculators. If anybody... For an equation of a what? Line. So to find the equation of a line, what do you need? Try to have a little more passion. Come on. I know it feels like a Monday. A point and what? A slope. How do you find the point? How do you find the point? Yeah, it's when t is equal to what? Pi over 3. It's the point when t is equal to pi over 3, and x of t is what? 3t. So it's x of pi over 3. So the point is just going to be 3 times pi over 3 is what? Pi. My writing is going to be worse because of the Band-Aid. Sorry. What does y equal? Y of t? What was that equation? It's cosine of 2t. Do you need to remember your basic trig? Absolutely. So what is y of pi over 3 going to be? It's cosine of 2 pi over 3, which is equal to what? Which is equal to? 1/2. I think, right? We got it? So what's our point? What's the point? Pi comma 1/2. We have our point. How do you find the slope? Well, you're... negative 1/2. Thank you. Excuse me. Yes. Well, dy dx, you know that that's equal to what? Dy dt over dx dt. So when you did dy dt, what'd you get? Negative 2 sine of what? Negative 2 sine of, it's just negative 2 sine of 2t, right? Isn't it negative 2 sine of 2t?
Yeah.
And what's dx dt? 3. So if you're, then what do you want to do? You want to do the slope when t is equal to what? So remember, t is equal to pi over 3. So we're doing negative, so m is going to be equal to negative 2 sine of 2 pi over what? Over 3. What's sine of 2 pi over 3? What's sine of 2 pi over 3? 3 over 2 over 3. So what do you end up with? Negative root 3 over 3. So what's our, oh, do we have our slope now? We sure do. Point and a slope. So can someone just tell me what the equation is going to be? Y plus what? Y plus, because it's minus a negative, negative half, equals negative root 3 over 3 times what? Minus what? Pi. Yep. There's different forms, but that's acceptable. I do not force you to go to slope-intercept form. Point slope is fine. That's excellent. Now, on the second part, it says find the smallest positive value of t for which the y-coordinate is a local maximum. What's the only thing you're really looking at for part B? What's the only thing you really need to set equal to 0? dy dt. dy dt. It's a local maximum when it stops going up and down for a split second, right? So what was dy dt? Do you remember what it was? Negative 2 what? Sine of 2t. And if it's not going up or down, what does dy dt have to equal? If it's not going up or down, it has to be 0. So we do negative 2 sine of 2t is equal to 0. And this is where people were tempted to go a little too quick. If you do this, you know that sine inverse of 0 has to be what? 2t. What is sine inverse of 0? The sine of what is 0? 0 or pi or 2 pi or 3 pi or 4 pi. So that's, what's the, how do you write that out? N pi or k pi. Either way. Let's say, fine, n pi equals 2t. So what does t equal, Chip? N over what? 2 pi. But what's this question asking you? It's asking for the smallest positive y value. So can n equal 0 here? No, because 0 is not positive. 0 is not positive. 0 is not positive. 0 is not negative. 0 is not positive. So the possible answers here, what are the possible answers? 0, pi over 2, then what? Pi, then what? 3 pi over 2, and then what? 2 pi, right? What's the smallest positive value? Pi over 2. That is the smallest positive value. How do you feel about what we've done so far? How do you feel about what we've done so far? It's getting a little harder, right? It's getting a little harder. It's getting a little tiny bit harder. Part C is where it gets fun. It says, find d... What is this, if you had to say this out loud? That is the second derivative of y with respect to x. The second derivative of y with respect to x. And this is what you have to remember right here. See this, everybody? What do you calculate first when you're evaluating that? What do you calculate first? You calculate what? dy dx. Have we already done dy dx? Yeah, what was dy dx? Remember what it was? It was negative what? 2 sine 2t over what? Over 3, right? And now what do we do? What does it tell us to do? Take the derivative with respect to what? What is that derivative with respect to t? Negative 2. Nope. Yeah, it will be eventually. You guys are saying the same thing. You're just doing chain rule at different times. Yes. So it's negative 2 cosine what? 2t times what? Over 3, right? Do you agree that that's true? Now, what do we still have here, though? What's the dx dt? 3. So where's that going to go? Right there. So what do we have here? Negative what? 4 cosine 2t over 9. And it asks, find it when t equals 2. What does this tell you about the concavity at t equals 2? What do you plug in? So negative 4 cosine of 4 over 9. Now, are you expected to know what the cosine of 4 is off the top of your head? But it's more than pi, right? It's down in that third quadrant, right? So cosine is going to be what? So this, all you need to know is that this is what? Negative. So this whole thing is positive. So positive means concave up. It's concave up there. That's what it means. The key is, the biggest mistake kids make when they do this is they do the first derivative of y with respect to t, and then what do they do again? They just do it again. They do dy. They do it twice. You need to do it this way right here. Yes, Nam?
On B, like
yep.
On B, do you have to check for
t equals pi over 3, right? Pi over it's pi over
2.
Oh, was it pi over? Oh, that was the smallest. Yeah, pi over 2. Well, plug in pi over 2, you get cosine of pi. What's cosine of pi? Negative 1. Negative 1 times, oh, it's going to be positive. It's concave up, so it's going to be a minimum. So you might need to go further. So our answer of pi over 2 was actually a minimum, so we need to go further. That's a really good thing to check. I just wanted us to get the second derivative. I think that's over, right? Because it's 10:05.